one of the very interesting thing about robotics is that what you can measure in a robot is typically what is happening at each of these joints, whether it's position, angular velocity, or torque. But the net effect that you want is always at the tip of the robot, right? So imagine you are using a robot in an industry to, let's say, do some machining. Then you put the tool at the end, right? If you want the robot to do some pick and place, then the end of the robot is what is picking and placing. But you are not measuring anything there. So you want to be able to use these measurements to figure out what is happening at the end of the robot, right? And that is what is called forward kinematics. When you're using position, in this case, when I say position, I mean angle of the joints, or velocity, angular velocity of the joints, to figure out what is the end tip position or end tip velocity. That is forward kinematics. And as you can imagine, it depends on some orientations, and it depends on some linear transformations, because from here, how much distance is this joint, how much distance is the other joint, and so on and so forth. So you can get into all of that calculation, but you can also just use it as a pre-built function, where given measurements at these joints, you directly calculate what is the end tip doing. And there are typically three different things you can do: position of the end tip, velocity of the end tip, orientation of the end tip. So you can have position forward kinematics, orientation forward kinematics, velocity forward kinematics. But in simple terms, we club all of those together and say forward kinematics. The inverse kinematics problem is the opposite of that. Sometimes we know where we want the end tip to go, and we want to figure out what needs to happen at the joint for that to happen. So let's say I want to pick up an object from this location. So I want the end tip to go here, and I want a certain orientation of the end tip. Then what would all the joints have to do? So that calculation is called inverse kinematics. I am given my desired end effector position or orientation and velocity, and I want to find what should happen at the joints. And this is typically a much more intricate calculation. But again, fortunately, there are many methods out there. And as a user, you can again use a pre-built function where you just feed in your required end effector position, orientation, or velocity, and you get back what needs to happen at the joints, so that you can directly then issue those commands to the motors, and you can make that happen. This is forward kinematics and inverse kinematics in a nutshell.